Tensors are mathematical objects that transform in a special way when the basis vectors change. Understanding tensors is fundamental to understanding the curvature of space-time in Einstein's general relativity. A tensor of rank 1 is a vector. Let's pick new basis vectors. We typically describe a vector by how many of each of the basis vectors we have to add together to produce it. But there is also another way to describe a vector in terms of the basis vectors. This is by taking the dot product of the vector with each of the basis vectors. For now, let us return to the typical way of describing a vector. Here, the vector has the components 4, 2, and 6. Suppose we double the length of each of the basis vectors. The components of this vector are now 2, 1, and 3, which means that the components have decreased. When we increased the lengths of the basis vectors, the components of our vector decreased. If we decrease the lengths of the basis vectors, the components of our vector increase. Because these two quantities change contrary to one another, we refer to this by saying that these are the contravariant components of the vector. Describing a vector in terms of the contravariant components is the way we usually describe a vector. Suppose we instead describe the vector in terms of its dot product with each of the basis vectors. If the basis vectors are of length 1, then the result of these dot products will be these 3 lengths. If we double the length of a basis vector, then its associated dot product will also double. When we increase the lengths of the basis vectors, the dot products also increase. When we decrease the lengths of the basis vectors, the dot products also decrease. Because both quantities vary in the same way, we refer to this by saying that these are the covariant components for describing the vector. We can distinguish the variables for the covariant components from variables for the contravariant components by using subscripts instead of superscripts for the index values. We can distinguish the variables for the covariant components from variables for the contravariant components by using subscripts instead of superscripts for the index values. Since these are just 2 different ways to describe the same vector, the same variable name is used, which in this case is the variable v. Suppose we have 2 different vectors. Let's call the first vector v and the second vector p, and let's always continue to use these names even if the basis vectors change. Suppose we multiply one of the contravariant components of V with one of the contravariant components of P. If we consider every possible way in which we can do this, we would get a matrix as shown. This is an example of a tensor of rank 2 with two contravariant index values. Suppose we multiply the covariant components of V with the contravariant components of P as shown. This will give us a different description of the same rank 2 tensor, with one covariant index value and one contravariant index value. Suppose we now instead multiply two covariant components from each of the two vectors as shown. This will give us a different description of the same rank 2 tensor, with two covariant index values. What makes a tensor is that when the basis vectors change, the components of the tensor would change in the same manner as they would in one of these objects. A tensor does not necessarily have to be created from vector components, as is shown in these examples. A tensor of rank 1 is a vector. A tensor of rank 1 has a number associated with each of the basis vectors. In a tensor of rank 2, instead of associating a number with each basis vector, we associate a number with every possible combination of two basis vectors. In a tensor of rank 3, we associate a number with every possible combination of three basis vectors. A tensor of rank 3 can be composed of the combinations of components of three vectors. We can create different descriptions of this tensor by using different combinations of contravariant and covariant index values for the components of the three vectors.